reflected rays does that appear to converge or actually converge, and so no image will be formed. Okay, but the advantage of this is that it brings about the evenly distribution of light and heat energy from the sun. And I said that because the surface of the earth is irregular, okay, when the incident light from the sun, when it hits incident on the surface of the earth, it is distributed or reflected in different ways. That is the reason for which no matter where you find yourself, rays, light from the sun could reach you, reflected rays from the sun could reach you for us to see, and then for us to experience warmth. Is that okay? Then we talked about characteristics of images formed by a hammer.
Yeah, please, I want to ask a question. Please, you said that the earth is irregular and
the surface of the earth.
Okay, the surface of the earth is irregular.
Yes.
And it enhances viewing. So you just said that irregular reflection does not form any image, like virtual image or something. But say if the if the beam of light enters our eye, we're able to see people clearly, like we're able to see their image. So do you understand what I'm trying to say?
I do.
Yeah.
So I'm also
I want to understand why an image has been formed. An image has been formed.
We see as a result of reflection, and the main source of light on the surface of the earth is from the sun. So the light from the sun must shine on things around us for light to reflect from the object into our eyes. Okay, so Amma, it's as if you are here and I'm looking at you. Before I can see you, light from the sun has to incident on your body, then reflect into my eyes. So when I get reflected light from the sun, then I can see you.
So
is that okay?
It means irregular reflection and regular reflection occurs at the same time.
So what? Yes, because the surface of the earth is irregular, the light from the sun, okay, beams on the objects around, and it is thrown in different directions into viewers so that we can pick light from the objects. Is that okay?
Yes, please.
The sun simply distributes the the earth surface of the earth, objects on the surface of the earth distributes the light from the sun in different directions so that no matter where you find yourself, you can get rays from the sun reaching you. And when rays from the sun reach you, then an observer can see you.
Okay.
So that's all. Okay.
Okay.
Then we talked about characteristics of images formed in a plane mirror. Characteristics of images formed in a plane mirror. If you look at yourself in the mirror, how does the image of you in the mirror, okay, look like compared to you the object? What you see in the mirror is the image, and you, Adjoa Asante Otubia, you, Chrysla, you, Lizzie, is the object. So whenever you see yourself in the mirror, what is the characteristics of the image of you formed in the mirror? Chrysla, give me one.
I am laterally inverted.
What does it mean?
Like my left becomes my right, and my right becomes my left.
Okay, so the image of crystal in the mirror looks turned upside down laterally, horizontally. Okay, this is your lateral side, so it looks turned this way. Okay, Ajua Santi, when you look at yourself in the mirror, how does your image look like relative to you, the object?
Please, my size doesn't change.
Your what?
Size.
Doesn't change. So Ajua's head is still as the head. Ajua's size doesn't change. Okay. What again? The object distance. The distance from the object to the mirror. And the distance from the mirror to the image remains the same. Okay. What again? More views. Characteristics of images formed in a plane mirror. Bushra, another point. Characteristics of images formed in a plane mirror. Bushra, are you there? Hey, Bushra. Okay. Somebody. Yaba. Image is what?
The image distance from the mirror is the same as object distance from the mirror.
Okay. Then we also talked about the image being virtual. Images formed in a plane mirror can never be formed on a screen. And if an image can never be formed on a screen, then it means the image is virtual. So virtual images can never be formed on a screen. Real images can be formed on a screen. Okay. All right. If you don't have any question, let's continue from where we ended. If you have any question, you can ask. Okay, today we are going to look at formation of images. And then we also talked about laws of reflection. We also talked about the laws of reflection. What is the first law of reflection? What's the first law of reflection? So anybody can answer. Yes, go ahead.
The first law of reflection states that the incident ray, the normal light, and the reflected ray at an angle of incidence are all found on the same plane mirror.
So the incident ray.
Hello.
Hello, I can hear you. The incident ray, the reflected ray, and the normal,
Hello.
all at the point of incidence lie in the same plane or place. I can hear you. Okay. Then the second law. Somebody to tell me about the second law of reflection. Yaba.
The reflected angle is equal to the incident angle.
Yaba, I won't take reflected angle.
Angle of
so the angle of incidence is equal to the angle of reflection. Angle of incidence comes first before the angle of reflection. Okay. So angle of incidence equals the angle of reflection. So if this is a medium, and then if you draw an imaginary perpendicular line to the medium, this perpendicular line to this is called the normal. So the normal is always perpendicular to the surface. Okay. When you incident line, this is the incident ray. So long as this is a well-polished surface, even if it's not well-polished, when the light hits on the medium, part of it will be reflected. Though small percentage will be reflected. And then part of it will be reflected. The portion that is reflected, the angle between the normal and the incident ray is the angle of incidence. And then angle between the normal and the reflected ray, this is the reflected ray. This is the angle of reflection. And the rule says that angle of incidence is always equal to the angle of reflection. So if this is 90, this will also be 90 degrees. Please, are you okay? Class, are you fine?
Yes, please.
Okay, if that is it, then listen to this question. A ray of light strikes a plane mirror. Put the question down. A ray of light strikes a plane mirror. At an angle of incidence equal to 35 degrees. A ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. The angle between the incident ray and the reflected ray is 1 minute. Just 1 minute, somebody to give me an answer. The angle between the incident ray and the reflected ray is, yeah, so it's true. Yeah, you don't need calculation. Lizzie? Yaba? Priscilla? What's the answer?
70 degrees.
It's 70 degrees, that's all. It's 70. So if you are told that the angle between the incident ray and the normal is 35, but we just said that angle of incidence for angle of reflection. So if this is 35, this is also 35. This angle is the angle between the incident ray and then the reflected ray. So it must be 70 degrees. 35 plus 35 or 2 times 35. Please, are we all okay?
Yes.
Are we? Simple question. Now, when a ray of light incidents on a surface, here's the reflection. I is equal to R. This angle is the angle of incidence. This angle is the angle of reflection. We call this angle the glancing angle. So let's take this to be theta. So theta is called the glancing angle. So the glancing angle is the angle between the mirror and the incident ray. The angle between the mirror and the incident ray is known as glancing angle. So when I talk about glancing angle, you must be able to identify. When I talk about incident and reflected ray, you must be able to identify them. Now, the next angle we'll talk about is the angle of deviation. Angle of deviation. So the glancing angle is the angle between the mirror and the incident ray. Let's also see what we mean by the angle of deviation. This is the normal. The normal is always perpendicular to the surface. Incident ray Ideally, so when the ray hits the surface, it reflects in this direction. Ideally, we expect the ray to move straight. We expect the ray to go undeviated. But we see the ray to be deviated through this angle. This whole angle, let's call it alpha. So theta is the angle of the glancing angle, whereas this whole angle, alpha, is the angle of deviation. The ray is supposed to go in this direction, but something happens and it is deviated to this direction. And so, can somebody help me determine the angle of deviation alpha? So alpha is equal to angle of deviation. Per diagram, please. It is not in all situations that alpha is used to represent the angle of deviation, but we have chosen to label the angle of deviation by the letter alpha. Theta in this context is also the glancing angle. So we are representing these terms with our letters or symbols. Can somebody help me determine the angle of deviation? Do some thinking through. And let's see. Adoma.
Mr. Jeffries, I'm trying.
Right.
Okay, I think you use angle on a straight line.
Okay.
Because if they give you the angle of incidence and they give you the angle of reflection, and then you find the glancing angle, then you use that to find the angle. You use the angle on the straight line formula. So all of them will be cut to 180 degrees.
So, Adoma, I want you to use letters to represent and give me an expression. Okay. Oh, let the angle of it's a good point you are telling me, but I want you to think through. Maybe let X represent this and then get a relation for the angle of deviation for me. Another hand is up. Please go ahead.
I think that it is 2 times the angle of reflection or angle of incidence.
Nice attempt, but Inshira, you are getting closer. But you are not there yet. Come again. Okay. If another hand is raised, go ahead.
2 times the glancing angle. That is 2 times theta.
Yeah, but you have also done well, but not absolutely. Ama Shamima. Go ahead.
So please, the asking where the imaginary line is at. Between the imaginary line and the mirror, we use theta to represent it. No, we use A to represent it. So the deviation will be equal to theta plus A.
Theta plus A. Anyway, well done, but not 100%. Okay, let me come in. Oh, Adoma, you want to finish it? Chrysler, try and make it crystal clear for me.
I'm just trying to say, yeah, I think it
Uh-huh.
will be like angle of incidence plus the glancing angle in it.
Anyway, nice attempts. Okay, time. Let me polish it. Let's the
Mr.
angle
Deputy,
of Ekuya.
please, alpha is
Ekuya, go
equal to
ahead.
90 degrees.
Pardon?
Is equal to 90 degrees.
90 degrees. Ekuya, nice attempt, but I won't buy it. Okay, let's look.
Yeah.
Hey, Eurasi. Okay, last one, Eurasi.
Mr. Dia, please, I think theta over here will be equal to the angle of incidence. So let's make angle of incidence A.
So you let me
Hey,
clear.
sorry, theta will be the angle opposite it. Say the one by the side, no,
Okay, just
in front of this one.
I've cleared theta. So use your letters to represent whatever information you want to.
Okay. So glancing angle is A,
A,
and then the angle opposite it next to
side.
the is B,
is B.
where A and B are equal.
By what means? How do
Because
you?
because if angle of incidence is equal to the angle of reflection, then means those two angles will be equal.
Nice analysis. Okay. So
So
you are saying we can also call this as A.
yes, so that one is A.
Mhm.
So therefore, if the how do you even call it? The incidence ray hits the
Mirror.
normal. Yes, the normal. Meaning the angle on the left side will be equal to that of the right side.
Okay. Rezi, I think you've made a very nice analysis, bro. In fact, because of time, let me
Mister.
pick it. Okay. Let me pick it. Okay.
Oh, okay.
Let me continue from Eresi's analysis. Eresi,
Okay.
yes, you are right to say that if this is A, this will also be A. But one other thing you overlooked was this. If this is A, then this will also be A, isn't it? If this is A, this angle between the mirror and then the extended line of the incident ray would also be A. Please, do you agree with me? Vertically opposite angle. Vertically opposite angles. This angle and this angle. Right? Okay.
Thank you.
Good. So what you can say is that if you know A, this whole angle is what we are calling as the angle of deviation alpha. So if you know the glancing angle, alpha can be equal to 2 times the glancing angle A. And it will work. Another point is this. If this is I, this is also I, correct? Because angle of incidence is equal to angle of reflection. So if this is I, the angle of reflection is also I. Agreed? Hello? Agreed?
Yes.
Good. Now, Ekuya, you were talking about angle on a straight line. Yes, this whole angle is 180. So if I have this to be equal to 2i, when I subtract 2i, which is this, from 180, I can get the other remaining angle. So I can also say that the glancing angle is also equal to 180 minus 2 times I. Sorry, the angle of deviation is equal to 180 minus 2 times I. Do you agree with me?
Yes, please.
So these are the you can also say that since I is equal to R, if you know R, you know I. So alpha can also be 180 minus 2 times R. So either,
Yeah.
hello,
Since the theta, is that affecting the upper part or the lower part, or both the upper part and the lower part?
no, I haven't included the theta. Erase represented theta by A, and that's what I'm working with.
Sorry, I mean alpha.
The
Alpha.
alpha is the angle of deviation. The incident ray ideally must go straight, but something happens and its path has been deviated to the path of the reflected ray. Okay, so the angle between the actual path and then the now reflection is the angle of deviation, which we are representing by alpha. Please, is that Eresi?
Mr. Dia.
Eresi?
So if let's say you have been given the glancing angle,
Yes.
and then you are supposed to find the
Angle of deviation.
no, sorry, you've been given the angle of deviation, and you're supposed to find the glancing angle. You're just going to divide it by 2, right?
Oh yes, it will work. Let's use
Okay.
real values.
Okay.
Let's assume that this is the angle of incidence is 60 degrees. Once this is 60, it means this is also 60. Right? So if I'm to calculate for the angle of deviation, it is this angle. Once this is 120, automatically this angle is also equal to 60, correct? The angle of deviation is also equal to 60. Class agreed? Do we agree? Oh, do you agree with me here?
Yes, please.
So 60 plus 60, 120. So 180 minus 120, this will also be 60. But Eresi,
Mr. Dia.
if this is 60, what will be this angle?
30.
30. What will be this angle?
30.
So look at something. By vertically opposite angle, this is 30. What will be this angle?
30.
30. We earlier applied this and got the angle of deviation to be equal to 60. When you add this and this, isn't it 60?
Yes, sir.
So both ways would work, but it depends on what information the question gives you. Is that okay?
Okay. And so this applies to only plane mirrors.
Yes, it applies to only plane mirrors.
Okay. Thank you very much.
When it comes to, you will also lenses and all that, you look at how that also works. A question. Get ready for a question. Two plane mirrors are positioned. Two plane mirrors are positioned perpendicularly to each other as shown. They are positioned perpendicularly to each other as shown. I'll draw it for you. A ray of monochromatic red light. A ray of monochromatic red light
Yeah.
Hello.
Please, could you spell it?
Oh, mono.
Wait.
Monochromatic, meaning one color light. It is
Thank
a ray with one color. Red, monochromatic red light is incident on mirror 1. A ray of monochromatic red light is incident on mirror 1 at an angle of 55 degrees. Here clearly, once it is incident at an angle, it is the angle of incident. A ray of monochromatic red light is incident on mirror 1 at an angle of 55 degrees. This ray is reflected from mirror 1 and then strikes mirror 2. This ray is reflected from mirror 1 and then strikes mirror 2. I determine the angle at which the ray is incident on mirror 2. I determine the angle at which the ray is incident on mirror 2. I draw the ray of light as it is reflected from mirror 2. I draw the ray of light as it is reflected from mirror 2. All right, so let's go through this. Since this is your first major question on this, I think I have to go through this with you, else solving it becomes difficult. Okay, so listen to how the question actually goes. All right, I'm coming in. So the question says that two plane mirrors are positioned perpendicularly to each other as shown. So we have two plane mirrors that are positioned in such a way that they are perpendicularly connected to each other. So the angle between them clearly must be 90. Okay, so this is mirror 1, and this is mirror 2. Mirror 2. They are positioned perpendicularly to each other. So that's the first information. Then the second information says that a ray of monochromatic red light is incident on mirror 1 at an angle of 55 degrees. So since a ray will be incident on mirror 1, let's draw a normal, because the angle is always taken from the normal. So if this is the normal, a ray is incident here. The angle of incidence is 55 degrees. All rays must be shown by the arrow. This ray is reflected from mirror 1 and then strikes mirror 2. So the ray is reflected from mirror 1 and then strikes mirror 2. So this is the reflected ray from mirror 1. Angle of incidence is equal to angle of reflection. So if this is 55, this is also 55. Once the ray strikes mirror 2, the reflected ray of this becomes the incident ray. So you must draw another normal. So to mirror 2, this is the angle of incidence. Yes, once it strikes a mirror, it will be reflected and still obey the law of reflection. That angle of incidence equals angle of reflection. So this line also becomes the angle of reflection for mirror 2. We don't know this angle, and so we don't know this yet, but they'll all be equal. This is how the ray hits the mirror. So this is the drawing. And that answers question 2. Question 2 says that draw the ray of light as it is reflected from mirror 2. This is how it will be reflected from mirror 2. Okay, so the angle of reflection of mirror 1 becomes the reflected ray of mirror 1 becomes the what am I saying? The reflected ray of mirror 1 becomes the incident ray of mirror 2, and this is how it will be reflected. Please, any question? Before we look at the calculation. So, incident reflected, but the reflected ray, which behaves as the incident ray to mirror 2, would also strike the mirror 2 and then reflect again. So this is how the whole ray diagram within the 2 mirrors will look like. All right, then let's look at the question. Determine the angle at which the ray is incident on mirror 2. We have to determine the angle at which the ray is incident. Okay, Rach Love, please mute yourself. Mute yourself. Gifty. Okay, so determine the angle at which the ray is incident on mirror 2. We are looking at this angle, the angle of incident. How do we determine it? If this is 50, this is 55. What will be this angle and what will be this angle? It's calculated for me. What will be the Granson angle if this is
35. 35.
So the whole angle is, this is 90. So this will be 90 minus 55, which is 35. So the Granson angle is 35. And so this angle would also be 35. Now we have a right angle triangle. We know this angle, and so we can easily determine this angle. What will be the glancing angle to mirror to? What is the glancing angle with respect to mirror to?
35 degrees.
Mirror to. Is that 35?
Yes, please.
Yes. Okay, so this is also 35 plus 90 plus the unknown, assuming is A, is equal to 180. Or once this is 90, it means this plus this must also be 90. So when I subtract this from 90, I get this. So or A is equal to 90 minus 35. When we use the first one, A will be equal to 180 minus 125, right?
Yes.
So A is 55 degrees. When we use this, we equally have the same results, 55 degrees. So the glancing angle to mirror to is 55. Then what will be the angle of incidence to mirror to? What's the answer?
35.
Yes. Okay. So the angle of incidence to mirror to would also be 35 degrees. Please, is it understood?
Yes, please.
Please.
I'm going to give you one. I want to
Mr.
see.
Dia,
Go ahead.
please, I want to ask a question.
Go ahead.
Okay, so Mr. Dia, please, can you say that the glancing angle with respect to mirror 2 is is that alternate or something to
No,
the angle of this one?
From this perspective, you can see it.
Reflection.
You see, from this perspective, you can see it. There's a
Sorry, can't
normal.
see.
I'm coming. I'm coming. You can say that from this perspective. If you extend the normal, and this is 35. This angle is 35. Then it's alternate with this angle. Is that okay?
Okay, but so it's not always like that.
Oh, in this particular context, it's works, especially because of the relationship between the two mirrors. Okay.
Okay.
All right. So a question for you, and listen to it attentively. Two plane mirrors, M1 and M2, are inclined at an angle theta as shown. So let me draw it for you. Two plane mirrors. This is M1. This is M2. They are inclined to each other by an angle theta. This time is similar question, but this is 90, this is theta, acute. Now, a ray of light 1 which is parallel to M1. So we have a ray of light 1, which is parallel to M1. So we have a ray of light parallel to M1. So ray 1 is just parallel to M1. Strikes M2, yes. So the ray of light 1 parallel to M1 strikes M2. And after 2 reflections, okay, so the ray strikes M2, ray 1 parallel to M1 strikes M2, and after 2 reflections, so 1 reflection will be this. So I've drawn one of the reflections. And after 2, let's go to the question. And after 2 reflections, the ray 2 becomes parallel to M2. So after 2 reflections, the ray 2, this is ray 1, L1. Okay. After 2 reflections, the ray 2 becomes parallel to M2. So 1 reflection, and this is another reflection, and this is ray 2. Ray 1, after 2 reflections, 1, 2 becomes parallel to M2. Two plane mirrors M1 and M2 are inclined at an angle theta as shown. A ray of light 1, which is parallel to M1, strikes M2, and after 2 reflections, the ray 2 becomes parallel to M2. The ray 2 becomes parallel to M2. Find the hello.
Mr. Japi, so the ray 2, is it from the point of incidence to the other point of incidence on the first mirror before
Yes,
it moves parallel?
it's the same thing. Ray 1 initially parallel to M2. After 2 reflections, 1, 2, ray 2, which is this, is parallel to M2.
So sir,
Okay.
the ray 2 is not the one that hits the mirror.
The ray 2 is what hits what you see,
Mirror.
the whole thing is on ray 1. Ray 1, after hitting this and reflecting twice, this and this becomes L2. And L2
Okay.
becomes parallel to M2. Now the question is that find the angle theta. Find the angle theta. So think through it. Let me give you about, I think 5 minutes will be okay. Let me give you 5 minutes to think through. Please, I'm not insisting that you solve the question, but think through the question for me. If you are able to solve it within the given time frame, if you are not able to, we'll discuss it, okay? So 5 minutes, think through, compare it with the first question we just solved, and just think through. Let's see what you can do. All right? Okay.
Okay.
Yes.
Back from the commercial break. How far? Are you making any headway?
Yes, please.
Because your 5 minutes is over. Has somebody managed to get theta?
Yes, please.
Amma, what did you get for theta?
Sir, please. I used variables to get theta.
So what did you get for theta?
I got theta is equal to 180 minus
It,
two variables.
it should be a number. Theta must be
Sir,
a
but
number.
he didn't give any figure.
I know. I know.
We are good theta to be 30.
30. We shall see. I know. More views. Equia, what did you say? Equia, you got 60. Yes, more views. Okay, let's see it. So, to L1 is the incident ray, and this is incident ray to mirror 1. This is the reflection. So if this is the incident and this is the reflected, if I draw a normal here, we must have, if this is I, this is also I. Okay. But the point is that the first thing to look at is that, you see mirror 1, and the ray 1 are parallel. And if two lines are parallel, it means they have the same slope or gradient. So once mirror 1 is parallel to light 1, the slope, which is this, must be the same. So once this is theta, this must also be theta. So if this is theta, this is also theta. Please, are we there? So that
Please, please.
the angle of incidence, I is equal to 90 minus theta. So this I is 90 minus theta. Then this is also R, which is 90 minus theta. So because I is equal to R, they are all equal to 90 minus theta. What then will be this angle?
Theta.
This will also be theta. Because 90 minus theta plus this must be 90. And so if there's also 90 minus theta, This plus this must also be 90. So that's also theta. Then let's come here. The ray 2 is also parallel to M2. If ray 2 is parallel to M2, then it means that this slope must be the same as this slope. So if this is theta, this is also theta. I'm basing the two analysis on the fact that ray 2 is parallel to M2 and ray 1 is also parallel to mirror 1. So I'm only basing my analysis on two lines and a ray being parallel. If two lines are parallel, they have the same slope. So this angle is 30, and so this angle would also be 30. Okay, and straight away, this angle would also be 30. Sorry, theta. Because if we draw a normal, we'll have the same thing as we saw here. So 90 minus theta, 90 minus theta, and so this will also be 90 minus theta. So look at this triangle we have here. What looks like equilateral triangle. Same base angles, theta, theta, and then theta. So we have sum of angles in a triangle. 3 times theta is equal to 180. This plus this plus this. And so theta is equal to 180 over 3, which is 60 degrees. I think Ekuya got it right. So theta is equal to 60 degrees, class. Any question?
Please come again.
Okay, by special request, I must come again. So, Charlotte, ray 1 is parallel to mirror 1. And when two lines are parallel, they have the same slope. So if this is theta, this will also be theta. First thing. If we draw a normal to this, yes, this is a reflection of ray 1. Once we draw a normal to the incident, because the normal, the incident ray and the reflected ray all lie at the same point. So this angle will be 90 minus theta. So will be this angle, because I and R. If this is 90 minus theta, this will also be theta. Then the second reflection, ray 2. Ray 2 is also parallel to mirror 2. So this is also parallel to this. If two lines are parallel, they have the same slope. So the slope of this, the same. So if this is theta, this is also theta. If you draw incident reflected to mirror 1. So if you draw a normal, you have this angle also being equal to theta. 90 minus theta, 90 minus theta, and so this is also 90 minus theta. You have all the interior angles of this triangle. This triangle here. So when you sum up the interior angles to 180, you have theta to be equal to 60 degrees. Okay, are you fine?
Yes.
So That's the analysis. I'll send you a similar question. At least this kind of questions, I mean, forces you to think deeper. All right. Now let's look at when mirrors are positioned at various angles to each other, how do we calculate the number of images? Then we look at image formation in plane mirrors. So if you have two mirrors inclined at an angle theta, how many images will be formed? If you visited the barbering salon lately, or the hairdresser, when you go to the barbering salon and there is a mirror in front of you, there is another one in front of you, how do you see your image formed in such mirrors? If you have a mirror in front of you and then another one behind you, how do you see the number of images of you formed within the mirror? Yes, can somebody share her experience with us? Where two mirrors are arranged parallel to one another. Can somebody share an experience with us? Adumanjima, Agusia.
I don't know if this is the answer you want, but then if you look at the mirror in front of you, you get to see your back, like your back.
But I'm talking about if you have one mirror in front of you and then another mirror behind you, arranged perpendicular, parallel. Okay. How is the image formed? How does it look like? Or how many images are formed in mirrors that are arranged as such? Do we have any experience? Okay. Go ahead. Yaba?
I was saying,
Yaba,
You
share your
see a lot
experience with
of images. You see a lot of images, but then it gets smaller. The more the images, the smaller it becomes.
You see, okay, if two mirrors are arranged in such a way that they are perpendicularly or parallel to one another, in fact, you have an uncountable number of images formed. The number of images formed within you can't count. A lot. I'm talking about a mirror, one here, and another one here. And then there's an object here. Here, M1 and M2. M1 is parallel to M2. If you have this, you cannot count the number of images formed. Okay, so the number of images formed by two plane mirrors, just two. Number of images formed by two plane mirrors inclined at an angle theta is determined by this formula. Inshira Kwai, are you there? Inshira?
Yes.
Inshira Kwahen, I mean. Not ba, Inshira ba.
So this is bad uncle.
Ah, okay. So the number of images formed by two plane mirrors inclined at an angle theta is equal to this. Meaning, if theta is 30 degrees, if theta is 30, the number of images formed is equal to 360 degrees divided by 30 minus 1. This is for, I think, odd angles. Okay, we'll look at it. So 360 divided by 30, I think it's 11 because 3 goes into 36, 12. So we
12,
have
yes,
12 minus 1, which is equal to
11.
11 images. So if you have two plane mirrors and the angle between them is 30 degrees, 11 images will be formed. 11 images will be formed. Do this for 60. If theta is 60, 90, and 0. So theta 60, and then 5 images. Then 90 will be 3, I guess.
Yes.
90 will be 3. Then 0. Zero degrees. What did you get for 0? The calculator cannot calculate for you.
Math error. Yes, please.
That error means that you see, if you have a number and the denominator is equal to
Mr. Dear,
hello,
Mr. Dear, please reposition your camera. Thank you so much.
if you have a number, mute yourself, Adoma, Akusha.
Sorry.
If you have a number and the denominator is 0, mathematically, what does it mean?
Undefined.
Pardon?
Undefined.
Undefined.
What does it mean? Undefined. What does it mean?
0.
Pardon?
0.
0. No, it doesn't mean 0.
It doesn't exist.
Means yes, doesn't exist.
Eh,
Like it's you not get a normal number. You get complex numbers.
You get abnormal number.
No, you get complex numbers.
What do you mean by complex? Okay, let me explain that to you. If I have 1/10, and then I'm gradually decreasing the denominator, 1/9, then 1/5, maybe 1/4. Here, I'm dropping the denominator to close to 0. Then 1/2. 1/1. 1/0.9. 1/0.5. 1/0.2. 1/0.1. Eresi,
Mr. Dear,
hello.
please, is it like possible to get a decimal for the number of images formed?
Oh, with the angles we are considering, 30, 45. Okay. Yes, of course, when you use angle like 25, you get decimal. I understand what you are saying, but why a decimal number of, so we are interested in angles that will give us a whole number images, right?
Okay, but if you have a situation where it's a decimal, it's supposed to like round it or something.
And then the image is roughly that number. Okay.
Okay.
So usually we give definite angles that will give us whole number images. So
Okay, thank you very much.
So I have this fraction and I'm gradually decreasing the denominator to 0. So 1/10, 0.1. 1/9 would be greater than this. What's 1/9? Quick. 0.1 what?
1.
Okay. 1/5, 0.2. 1/4, 0.25. Okay. 1/2, 0.5. This is 1. 1/09, 0.9. One over 0.9.
1.11.
1.11. 1/0.5. 1/0.5.
2.
1/0.2.
5.
This is 5. This is 10. I think this is yes.
1,000.
So let's end here. You see, we could see from what we've done that as the denominator draws closer to 0, the whole quotient or value becomes large. Okay, when the denominator approaches 0, the whole fraction becomes large. So the moment the denominator is 0, it will be a very large value which cannot be calculated for you. So it's a very large answer which cannot be calculated, because the trend is that as the denominator decreases, draws close to 0, okay, the value becomes increasingly large. And so the calculator cannot do that for you. And hence undefined. So it means if you have a fraction and the denominator is 0, it's a very large value. Here kind of short, undefined. So that is the reason why if two mirrors are parallel, the angle between them is 0. If the angle between them is 0, when you use this, then that is Yaba. That's the reason why when two mirrors are parallel to each other, it forms a lot of images which you cannot count. Please, is that okay?
Yes, please.
So
Yes.
be opening your eyes when you visit the barbering salon and there is these two mirrors that are parallel. Look at the images formed by such an arrangement. It's a lot of images you cannot count, hence undefined. Any question? All right. Now let's briefly look at formation of the rules for formation of images in plane mirrors. We'll look at plane mirrors and then curved mirrors. Formation of images in plane mirrors. Please, the formula applies to only two mirrors. Okay. Inclined at an angle theta. Only two mirrors. Not three, not four.
Mr.
So,
Adria,
hello.
please, you said the formula applies to.
Only two mirrors inclined at an angle theta.
Okay.
So formation of images in a
Sir,
plane
please, can
mirror.
you tell Jill? Okay, thanks.
I've told her. So this is a plane mirror. Let's begin with what we call point objects. A point object is an object which looks like a dot or point. So how do I use ray diagram to form the image of this point object? Here we look at an extended object. The first rule of the game, rule 1. When a ray of light from an object hits a mirror perpendicularly, when a ray of light hits a plane mirror perpendicularly, it is reflected along the same path. So rays must be coming from the object. I said we see as a result of reflection. Light must incident on my body from the sun or from the source, and then be reflected from me onto the observer before you can see me. So we see as a result of reflection of light. That is why if there is no light in a place, seeing becomes difficult because your eyes cannot pick rays reflected from whatever you are viewing. So the rays must come from the object. But if the ray coming from the object O is such that it hits the plane mirror perpendicularly. It makes an angle of 90 with the plane mirror. Then the reflected ray moves along the same path as the incident. So we are all using the same footpath. You go by this road or path, and because you are hitting the mirror at 90, I also come by the same path. Hence, the meaning of these two arrows. Okay. So this is happening because the ray hits the mirror at an angle of 90 degrees. When a ray of light hits a plane mirror perpendicularly, it is reflected along the same path. Rule 2. When the ray hits it at any other angle, meaning apart from 90. When the ray incidents on the mirror, on the plane mirror, we are using plane mirror, so at any other angle, apart from 90, it is reflected. The ray is reflected to obey the laws or the laws of reflection. This is what I mean. If the ray of light interacts with the mirror other than 90, so maybe this angle. So here, once the angle tilts, then I'll need the normal. Then it will reflect in such a way that it will obey the laws of reflection. Angle of incidence would equal the angle of reflection, and incident ray, normal, and then reflected ray are all at the same place. So if we have another ray hitting the mirror at an angle, yes, there will be reflection of light. So a ray from here hitting it will reflect. And the reflection obeys the laws of reflection. Another ray, maximum 3, even 2 will do, but maximum 3. Another ray hitting would also reflect and obey the laws of reflection. So how then do we determine the image? How then do we determine the image? You see, an image is formed when 2 or more reflected rays actually meet at a point or appear to meet. When we look at this, we have 3 reflections. 1, 2, 3. We have 3 reflected rays. Do they look like meeting one day in front of the mirror? Class, do the three reflected rays, do they look like meeting in front of the mirror one day?
Yes, please.
Hello, class, are you there?
Yes.
I'm asking a question. Look at these three reflected rays. 1, 2, 3. Do they look like meeting in front of the mirror one day? Hey, you are not talking.
Yeah, please. I don't understand the question.
My question is that
Yes.
look at the three reflected rays. 1, 2, and 3. Do the reflected rays look like meeting one day? Would they ever meet? No, because as they move or as they go, they get more diverse. They get more diverse. So they will never meet in front of the mirror. Okay. Now,
Yes.
Rachel, mute yourself. Now, if the reflected rays could meet in front of the mirror, they will form a real image, but they will never meet. So we must extend the reflected rays so that they look like meeting. What do I mean by they look like? When I extend this reflected ray backwards, and because it's a virtual thing, that's why we are represented by broken lines. So you extend all the reflected rays. Backward. Oh, because it's freehand, it's not giving me an accurate thing. Next time I'll use a straight edge. So if you extend the reflected rays backward, then they would appear to be meeting at this point. Where they meet, they appear to meet will be the position of the image. But in doing this, you also need to consider that for formation of image in a plane mirror, object distance must be equal to the image distance. So you must measure this thing carefully. But because I use freehand, that is why I didn't factor that. Okay. But when the reflected rays actually meet, the image form will be real. If the reflected rays are not meeting, then you extend them backwardly or you extrapolate them in the opposite direction and they meet. The image form will be virtual because this image form is as a result of the apparent intersection of reflected rays. And whenever we have the apparent intersection of reflected rays, the image form is virtual. When you have a real intersection of reflected rays, image is real. So this is how the image will be formed, and this image will be virtual. Virtual because it is formed as a result of the apparent intersection of reflected rays. The reflected rays actually did not meet, but it appeared that they are meeting here. And this image will never be formed on a screen. That is the reason why you look at yourself in a mirror. When you take the mirror, the image is not there because the image form is virtual. Virtual image is not formed on a screen, and a virtual image is formed as a result of the apparent intersection of reflected rays. Ask your question. we'll be drawing it better for you to, picture it well. But if you have any question, quickly bring it up for explanation. Hello.
Please, can you position the phone more? Because I can't see the rules properly.
Come again.
I can't see the rules that you've written, so like, can you position your camera?
Can't you see?
The last part,
When the
the
ray
last
is,
part, yeah.
listen, when the ray incidents on the plane mirror at any other angle apart from 90 degrees, it is reflected to obey the laws of reflection. Okay, and what are the laws of reflection? The incident ray, the reflected ray, the normal, all lie in the same plane. And 2, angle of incidence is equal to angle of reflection. So incident, reflection, when I draw normal to them, they must be equal. They must be equal. We'll draw it properly. So, Amma, I saw your hand.
Mr. Adria, please, I want to know how the phone camera works. Like, how is it able to get a real image?
Is that how are you able to?
Please, I want to know how the phone camera works. How is it able to get a real image and not a virtual one?
The image, the phone camera has something on which the image is captured. It used to be, in cameras, it used to be film. The image formed by even our eyes, the eyeball, is real. It is formed on a screen. There's the retina of the eye is the screen. So the phone camera has something on which the image is captured. The storage. It used to be the film, okay, in cameras. Because of technological advancement, these days is the memory, the phone memory. So the image is actually captured on something, the memory. Is that okay?
Yes.
All right. So what I'll do is that, in fact, we will end here. We've now gotten into the zone of image formation properly. Now, in our next meeting, I'll bring a long rule so that we'll draw the image well and then apply the laws and techniques into it so well, so you can effectively understand. Okay, so today we looked at the point objects. In our next meeting, we'll look at point objects and extended objects. Then when we finish, we'll look at why in a plane mirror, how the image seems to be laterally inverted. We'll be doing all that. Then we'll go to spherical mirrors. Okay. All right. So if you have any question, please ask for a last clarification. Then we draw the curtains on our meeting today. Do you have any question? I will see Amma, Lizzie, Yaba, and Co. Inshira, I push Yadoma. Any question? No question. Okay, then this is why I draw the
So,
curtains.
Mr. Adria,
Resi.
so this drawing that is on the board right now, does it in a way have anything to do with like kind of like maybe the light travels in a straight line thing effect on it?
You see, yes, but unfortunately, the mirror is an opaque, it's an opaque material, okay? Because one end of the mirror is coated, it prevents light from passing through. In actual sense, if the other end is not coated, Then the light, when it hits it at 90, it's supposed to go straight. When the light hits the mirror at 90 and the back is not coated, the mirror is transparent, it's supposed to go straight. Now, when it hits at an angle, part of it will be reflected and part of it will be refracted. So the mirror is behaving as an opaque material because the other end is coated with silver. And that prevents light from just passing through it and getting reflected. Is that okay?
Yes, sir. So the light gets refracted.
Yeah, a greater if once the back is coated with silver, about 90-something% gets reflected, but the other component is absorbed within the material. It doesn't come out. It's
Okay,
absorbed.
okay, sir.
When we get to at a refraction, you also understand better, right? All right, so this is why we end today's session. Thanks for your time and then your contribution. We'll have another wonderful session on Friday. Okay, bye-bye to each one of you.